Good evening, gentlemen. Today we are talking about the as scheduled. As scheduled, the IS 103 Safety Engineering 2, wherein that 3.2.1 manufacture of basic metals, ferrous metals as well as non-ferrous metals. The manufacture of the basic metals like ferrous and non-ferrous, before going to the individual ferrous and non-ferrous, we will discuss about the what is ferrous materials and what is non-ferrous materials. Then we'll go to the individuals. Then this division includes the activities of smelting, refining ferrous, non-ferrous metals from ore, pig, iron as well as scrap, using the electromagnetic as well as the other process industries. Say for example, these are the raw materials where we can use from scrap material also. We can prepare the ferrous and non-ferrous materials also using the metallurgical process or other process metallurgical techniques are there, because in the world itself or in the India itself there are various the processing of the ferrous metals as well as the process of the non-ferrous metals, depending upon the mines, depending upon the ores, depending upon the nature of the ores, and depending upon the purity of the metal which is extracted, and depending upon the availability of the equipment also, we have to see that the organizations has to feasible viability as well as financial feasibility viability. I can go for the different methods. Before going to the methods,
Sir,
what is ferrous metals? Yes,
sir,
please.
sir, what is pig?
Pardon, sir.
Sir, what is pig?
Like pig
Can
iron,
you?
sir. Pig iron is a multi composition of the iron, sir. Wherein the, is a multi specification of the iron, sir. It's not a it's not a pig, sir. Pig iron I have to write here is pig
Okay,
iron
sir.
and scrap iron, sir. Sorry, it's a
Okay,
pig
sir.
iron and scrap iron, sir. Thank you. Therefore, the ferrous materials commonly used examples ferrous materials like include steel, stainless steel, carbon steel, cast iron, wrought iron. These are the some of the examples of the ferrous materials. What is the ferrous metals? Also, we will discuss one by one. Ferrous metals are pure iron or an alloy which typically consists of the iron. That means if you go to the steel, iron and carbon is there. That is why it is called typically consists of iron. The term ferrous has been derived from the Latin term ferrum, meaning iron. This is the history of the arriving of the ferrous metals named. The most common the ferrous metal alloys are steel. That means if you take the steel, it consisting of the iron and the steel is the iron and carbon is there. And ferrous metals contain little amounts of other metals or components added or rendered to it to requisite properties. We will discuss one by one in coming slides. These metals are magnetic, offer only slight resistance to corrosion. These are one of the important property when compared to non-ferrous material. The ferrous materials are magnetic properties they have, offer only slight resistance to corrosion also. So the all commercial forms of iron, steel, bare carbon, which has become an integral part of the metallurgy, iron and steel. See, for example, if you want what is called iron and steel is there, it's iron and carbon is there. It will be discussed in this. That's why here you can see a combination of iron and carbon is a steel renowned in the strength of measurability. Therefore, the preference of ferrous materials is quite strong. Thus, also making scrap metals highly merchantable. That means we can become a merchant by taking the scrap also we can prepare the ferrous materials. Most recycling companies pay fairly for scrap metals because the most of the companies are the ferrous industries or ferrous metal industries are based on the scrap only which is to be recycled for preparing the ferrous materials. The once again we'll tell the what is called this is the ferrous material and the non-ferrous material we talk about. This is very important point. Steel, stainless steel, carbon steel, cast iron, wrought iron are the examples of the ferrous material. And when compared to the ferrous materials, the non-ferrous materials are large number of covering every metal and alloy that does not contain iron. See, for example, these contain iron and some other substances are there, but it becomes an alloy. Alloy means combination of two or three metals combined together form as a alloy. Coming to the non-ferrous, which does not contain iron. Therefore, this completely domination of the iron in this, whereas non-ferrous means complete ferrous is zero. Aluminum, copper, lead, nickel, tin, titanium, zinc, copper alloys means bronze or brass. These are the non-ferrous examples of the various things. Apart from this, there are other also, but some of the things are here described here. Coming to the difference between the ferrous and non-ferrous before going to the individuals, ferrous metals contain iron and non-ferrous metals do not. That's what we learned. Non-ferrous metals are rarer, more available, more valuable, and resistant to corrosion than ferrous metals. Already discussed, the ferrous metals are resistant to corrosion, whereas the non-ferrous metals are not resistant to more than what is called this. Ferrous and non-ferrous metals can both recycle. In the process of manufacturing, both metals of the remaining after the preparation of the product, they can be recycled. The quality check is not passed. That means the both industries is the raw materials, the ferrous and non-metals can be recycled, can be used. Magnetizing the iron in ferrous metals can separate ferrous and non-ferrous metals also. Because of the ferrous metals attracts the magnetic properties. Therefore, any want to what is called mixing of the ferrous and non-ferrous is there. Use the magnet here. Therefore, immediately where the ferrous material attracted towards the magnet and non-ferrous is rejected for the magnet. That also one of the separation method is there. That's why magnetic properties, yes. The non-magnetic properties, no. The value in dollars here is, this is somewhat what is called the less when compared to ferrous material. This value becomes, and resistance to rust or corrosion very less as compared to non-ferrous. Recyclable, both are there. These are the some examples of the ferrous and non-ferrous metals and all. And then coming to the individual ferrous materials, the manufacturing process of the ferrous materials involves mining, iron ore, smelting, adding, alloying metals to create different types of. These are the various steps in preparing up the ferrous material by taking the raw materials of scrap and all. First is mining. Iron ore is mined from the earth. You know that the mines are there. From the mines, we can get the iron ores from the mines. That iron ore from the earth, it is coming. Everybody knows about it. Now smelting. Iron ore is smelted in blast furnace to separate the iron from the ore. See, the iron ore means the nominating percentage of the composition is iron is more, then only the mining iron ore can be used for making ferrous, because if the ore is contains the less percentage of iron than the impurities, it is not viable to prepare, or it is not viable to financially viable to the manufacture of the iron. That's why you have to see that in that mine, why it is called iron ore. It is not simply called as iron ore mining. Because in that mining, the ores are available and the ore is containing the percentage of the ore iron is more in that ore. That is why it's called iron ore. It is called. You can say the mining is available in the iron ore. That means percentage of the iron in the ore itself is more. That is why it is financially viable for the preparation of the iron. Iron ore is melted in blast furnace to separate the iron from ore. That means some of the impurities along with iron, first of all in the blast furnace, you have to separate the iron first. The coke, limestone and steel scrap are added to the furnace to help to remove the impurities. See, these are the one of the, we can combine all these things, gang we can say, JU and G. That means by adding the coke, limestone and steel scrap along with the ore in the blast furnace to help to remove the impurities along with the ore, it is coming by remaining the iron in the form of smelt form. Smelt, you know that the smelt is the intermediate stage between the liquid and this solid. Neither liquid or not a solid. It is intermediate stage. This process is produces iron, produces raw iron. This from this smelting in the blast furnace, the produces smelt is called raw iron. That means not having any impurities which is consisting in the iron ore. Adding of alloying metals here is to prepare the ferrous materials like this, eight of this. Now we are having the iron only presently from the blast furnace. Therefore, how do you prepare the steel as well as the stainless steel, carbon steel, cast iron, wrought iron? We have to prepare from that raw iron coming from the blast furnace. Therefore, uh, then adding of alloys to prepare any of the metals, carbon is added to create different types of steel. Other elements like chromium, manganese, silicon, sulfur, and phosphorus can also be added to create different types of steel. Steel means they are having the different styles of steel, having the thickness, having the quality, having the what is called withstanding with the high heat, withstanding with the resistance to heat as well as the pressure. Different types of the use. We can say steel cookers also it's coming. Steel the aluminum cookers is also there, and indalium we called indalium is also there, and we have what is called some bottom materials also now manufactured, which is suited to the electrical stove also. That's what we are taking care of. The arm elements like to get the additional properties for the steel to attract the customers. We have to add chromium, manganese, silicon, sulfur, phosphorus can also be added to create different styles of steel also, because it depends upon the cost viability and the selling process also will be see whether the customers is attracted or not. We have to see that also before going to that. Alloying elements increase the strength. That's why by adding these alloys or by adding these materials to the iron, which is coming from the blast furnace, definitely it increases the strength. Not only it increases the strength, it becomes hardness and wear resistance of the steel, because it will resist to the high temperatures also. Therefore, adding up the materials like this with this raw iron, depending upon the organization interest as well as the cost viability as well as the financial availability also. Coming to the creating different types of ferrous materials as we are discussing, cast iron, wrought iron, stainless steel. The coming to the cast iron is an alloy of carbon, iron, carbon, and silicon. What is the use of this? If you prepare that raw iron from the blast furnace, adding carbon and the silicon, you prepare a cast iron. which is having the properties of hard and brittle, and is often used in make machine beds as well as the frames also. We will discussing the applications and uses of the ferrous materials coming in the slides also, but at a glance I am giving here is an alloy of carbon. That means cast iron means maximum amount of the iron and then percentage of the carbon and some percent of the silicon. I'm not going to be details in how much percentage iron, how much percentage of the carbon, how much percentage of the silicon in the cast iron. That is scientific methods. We cannot go for that much of beyond onto the subject. The cast iron is hard and brittle and is often used to make the machine beds, because where the bed materials are there, like for example, pump and motor bed materials are there, you can go to use the cast iron also, because cost effective also we can see. Simply steel cannot be, or stainless steel cannot be used, because the cast iron having the less cost than so the frames also can be used for the cast iron. Uh, the wrought iron is an alloy of iron and slag. That means where the iron and slag, which is the mixture of, the slag is a mixture of silicon, sulfur, phosphorus, and aluminum oxides. These are combinedly called as a slag. If this slag and the iron from the blast furnace is coming, that iron and this slag, if you mix with this, then prepare one molten form and solid form, that becomes a wrought iron. That means wrought iron means it consists of the iron and slag. In bracket, the slag means either mixture of silicon, sulfur, phosphorus, aluminum oxides also will be there in the wrought iron to withstand the various resistant materials and all these things. Wrought iron is also softener and more tensile than the cast iron. It is very, we can say tensile means having the stretching capacity is more. If the stretching capacity is less because it is a brittle, the more tensile means stretching capacity is more by putting some weight on this material, that is called tensile strength than the cast iron. This is more tensile strength than this cast iron, and it is often used where decorative work, structural components also. You can use that wrought iron also. Now you already know the stainless steel, an alloy of steel and chromium, which makes it resistant to rust and the corrosion. If you go for what is called this cookers and all, go for stainless steel only. We cannot go for the silver and all this thing, because where the corrosion resistance we should see that, because the eatable materials or fooding materials will be there, where we have to see the rust formation should not be allowed. That's why the stainless steel is more costly than these two. An alloy of steel and chromium, which is a costly material, if we add the steel and chromium into that raw iron which is coming from the blast furnace, definitely it becomes a stainless steel. That means stainless steel consisting of what? One is iron and steel and chromium. Steel means iron and carbon is there. Therefore, which makes it resistant to rust and corrosion. Stainless steel is often used in chemical industries, textile processings, and for marine applications also, where the requirement is not supposed to be corrosion, because they are exposed to the iron. They are exposed to the water. Water. That's why iron exposed to the water means immediately knows it becomes a corrosion. That's why it is used in the chemical industries, where some of the tanks is prepared in hazardous chemicals stored in the stainless steels. And textile industries also, not to perform what is called this rust formation, to improve the what we call the disimprove the textile fibers also. That's why they have to go for the stainless steel, as well as in the marine applications also. These two or three are very important: chemical industries, textile industries, as well as the marine applications. So these are the some of the different types of materials, including if you go to the types, already it is seen here. Different types of the ferrous materials and features here. Stainless steel, resistance to corrosion at glance. Cast iron, hard, brittle, strong, self-lubricating, economical. Mild steel, ductile, high resistance, high tensile strength due to low carbon content, and it cannot be toughened and tempered. It should be only a case of hardened. It also is called, we can say, high carbon steel. The hardest of the carbon steels are tough and malleable but less ductile. Other available types of ferrous alloys and ferrous materials include pre-cutting steel, construction steel, high temperature steel, low temperature steel, high stainless steel, and spring steel. These are the very important other available styles. And not only thinking these are the only iron and the only steel, but these other available steels also in small scale industries, they can prepare this. For example, pre-cutting steel and easily can be cuttable, prepared into small spoons or small vessels. Construction steels, for example, buildings, iron high temperature steel withstanding of the high temperature, a low temperature steel with a less temperature it will be melted. Then high strain steel. Strain steel means it is having the capacity of the, you can say the stretching capacity is more after the melting. And the spring steel is also there where we can use the in springs also we can see that will be stretch also. Brief manufacturing process of the ferrous materials. Ferrous materials needed to be extracted from the basic iron ore. First step is. Second, the iron is also, selection of iron is also very important. Suppose the number of minings in your area is, for example, 3 or 4. It's all iron ores only. But taking the laboratories, which mining is having the iron content is more, and which mining is viable ore for the preparation of the iron, you have to see that laboratory studies also. Unless otherwise the financially available, we cannot go for that mining. We can go for other purpose also. The original sources of iron ore is earth crust, which bears metals, metallic compounds such as iron oxide also. Definitely, if iron is there, definitely in the earth crust there is a oxygen is also available in the along with the ore also. That means what he want to say here is, author want to say here, a ore combination of the many materials along with the iron ore. However, the ore is commonly mingled with other metal. Definitely, the ore means combination of the other materials also, because it is coming from the earth crust. Various minerals also there in that, along with that ore also. Therefore, we can say for the purpose of the optimizing the usage of the metal, it has to be derived from the mixture. Definitely, it is a combination of the all materials will be available in the mines. Not only iron only itself is not available. You have to see that what is the dominating percentage of the metal is there that could be extracted from the ore by using the various process methodologies. The method principally used to derive, that means coming from or getting from or extracting from metals from the ores depends upon their reactivity. Excuse me. Because of the other impurities are having along with the ore, that means other impurities also we have to see that with your heat in the blast furnace, the other material which is combined in the ore, combined with iron, immediately it should be melted. Otherwise, if the other materials are taking much time to melt or what is called the become what is called taking the more heat, the economical it is not viable. That's why the method principally used to retrieve the metals before going to that ore available in that mine is financially available to prepare the iron or not depends upon their reactivity. Reactivities means not iron. Along with the iron, what are the impurities are there? That nature of impurities also we have to study and see that the reactivity with our alloy steels or not, it is coming out or not easily. We have to study in the laboratory studies also before going to the industries. With respect to iron, less reactive metal It can be derived from reduction with carbon and carbon monoxide. Where, for example, the iron is there, having the less reactive metal is there in the ore, we have to go for the reduction method or the calcination method. Different methods we will be discussing in the coming slides. The carbon and the carbon monoxide also. Because of the already told, it is having the ore is commonly having the oxides. If you send the carbon or carbon monoxide, oxygen will be removed immediately through the carbon dioxide and cells. That's why carbon and carbon monoxide helpful for removing the oxygen from the ore. Iron is then extracted from the iron ore in a big container known as blast furnace. Oxygen should be eliminated from the iron oxide to leave the iron behind. That's what immediate what is called it. Already other materials which is coming, which is along with the ore is there. First of all, they will separate first after reacting with the additional metals which are using in the blast furnace. Along with that, the iron, raw iron is coming along with the oxide. From that oxide, iron oxide, sending the carbon or carbon monoxide. Therefore, oxygen should be eliminated from the iron oxide and leave the iron behind. Therefore, iron can be manufactured by in the molten form. Required shapes can be prepared by the organization. They cannot give the in the steel factories only, steel plants only. They will give the channels, beams, as well as the rods and the pipes and the blocks and all. 10 minutes there, blocks are there. Now it is the preparation of the iron molds. There we can give the various customers in the form of steel beams or channels or the pipes or whatever. Otherwise, some people are taking only molds. That means only cast iron molds only. They will take molds and their organization said they will melt and getting the different shape. For example, the spoons, other kitchen utensils and all. These are the one of the typical diagram which we discuss about the manufacture of the ferrous materials and the process diagram. There are various metals are there. This is one of the process diagram. Go to the what is the applications you go for. Applications are there. Uses also there. Ferrous metals used in variety applications as sturdy crushing materials, nuts, bolts, grinders, girders, and plates, and they carry cylinder blocks, gear wheels, machine tool parts, machine handle, engine parts, vices, brake workshops, workshop materials, brake drums, and the plumbing fittings, gears, shafts, cutting equipments for lathes, kitchen, draining boards, and cutlery, aircraft and pipes, and the chisels, files, lathe tools, garden tools, hammers, drills, dies, taps, metal ores, springs, and wires. These are the various materials can be used from the ferrous metals only. You can use at that, they're taking the molds from the organization. Then at that organization, they will prepare, again, they will melt the ores and they'll prepare this various shapes they want. Environmental impact also we have to see because the human habitation is nearby your industry. They have to see that how the scrap is coming to the your organization. What is the transportation? We have to see that environmental impact also while going to install the organization also. Recycling of ferrous metals enables decreasing of quantities of solid waste. Definitely, where the recycling metals will be used for preparation of the melt, definitely the already metals are having the scrap only. It is consisting of all materials. The cost effective is less, which have what is called become a less costly when compared to other materials. That's why scrap can be guaranteed with the help of the magnet and sent to a recycling unit. Source of ferrous minerals, where the minerals are there, we can get the source minerals. We cannot discuss much on this way. Applications is there already discussed, and properties of minerals important areas. Ferrous metals may include a variety of alloying metal elements. Some examples are nickel, chromium, vanadium, molybdenum, and manganese. Those provide a ferrous steels properties that make them extensively used in the engineering. And coming to the following are the ferrous metal properties, already discussed in detail, but once again, durable with great tensile strength, generally magnetic, very low resistance to carbon, recyclable, and the silverish color, and excellent conductors of electricity. These ferrous materials are. These properties make them workable in constructions of long-lasting skyscrapers. For example, you can say towers, multi-storied buildings, and high-rise buildings. Besides, they are utilized in the manufacturing of tools, containers, pipelines, automobiles, and vehicle engines and cutleries. That means kitchen items also. What are the key points here is the key points about the ferrous metal is magnetic, susceptible to rust. Without proper treatment, ferrous metals are prone to corrosion, especially in humid conditions. Because we have to see that the magnetic condition is there, but due to because of more iron content is there. But we have to see that environment also. We have to see where the it should not be wet conditions. If you keep the any iron in nearby what is called, because iron attracts the water, it becomes prone to corrosion also. That means the storing of the iron is also ferrous metals are very important because of the percentage of iron is more. High strength and density generally considered as strong and heavy metals. A wide range of applications used in constructions, automotive, machinery. That's what we have discussed, and the manufacturing industry due to their versatility and availability. Versatility means and the cost effectiveness also. Some uses is there. Application is different from uses, as you all know, where the constructions, automotive, automotive industry, machinery, plumbing, cookware, hardware, railways, industrial equipment, decorative applications, tools and cutlery. These are the one of the specific uses of the ferrous materials. Other many uses are there, but we are used the specific uses: construction beams, girders, columns, reinforcement bars, building frames, and the structural components in buildings. Automotive industry, engine blocks, cylinder heads, axles, the chassis parts, brake drums, and the gear wheels also. Machinery, machine tool parts, gears, shafts, bearing, and cutting tools also. Plumbing, pipes, fittings, and walls. The we can say the skillets, pots, pans, and grills, as well as this cooking ware also, cookers and all these things. And the hardware, bolts, nuts, screws, nails, and rivets also, rivetings also. Railways also, railway tracks, rails, and the train components from the ferrous material because of the properties. Industrial equipment is mining machinery, crushing equipment, and the conveyor. In the mining itself, the machines are prepared from this ferrous material only. Mm, that means iron only. Mining machinery, crushing equipment, and conveyor belts also. Like example, the idlers, all these things will be prepared from the iron only. Decorative applications, fences, gates, railings, as well as ornamental iron work also are there, because the building gates and building design gates and all this are the windows, doors, as well as this uh, decorative applications also. Tools and cutlery, hammers, chisels, wrenches, and knives, especially with the stainless steel. Because once they go for the iron, we cannot we can use the because of the using the eatables and all these materials. We can say stainless steel is better to use because of the rust. Composition is also there. The primary element is here is iron, that is ferrous. That is most amount of the percentage of the ferrous material is iron, and defining characteristics, magnetic properties due to the presence of iron. And the examples of ferrous material steel, including sterlize, cast iron, wrought iron, we already discussed. Coming to the application of the ferrous materials, already discussed once again, cast iron, wrought iron, the carbon steel, and stainless steel. Already once discussed here is Then alloy of what is called this iron, carbon, alloy of iron, carbon, silicon, manganese, sulfur, phosphorus. It's used in the pipes, engines, and cookware. Wrought iron is iron. Domination is iron only. Iron alloy. Alloy means combination of the iron plus low carbon steel, where it is used in fencings, gates, and the ornament iron work also. Carbon steel, an alloy of a carbon, iron, alloy of iron and carbon is called carbon steel. We can say it is used in construction, automotive, and the machine building also. You can say the stainless steel, little bit difference is there in the carbon steel and where the cost is also more because iron, chromium, and sometimes nickel also, depending upon the strength of the stainless steel are withstanding with the temperature, withstanding with the heat, withstanding with the bearing the objectives in industries like this, whether we go for the stainless steel or not is because you know that SS316, SS310, SS316L, there are various types of the stainless steel properties also because it depends upon the properties to withstand the objectives, withstand the reactions like this. It's many properties it depends upon. That's why stainless steel having many types going for the an alloy of chromium, sometimes nickel also. That combination of this chromium, nickel, and iron is having more cost and more strength properties also there. That's why it is used in the, we can say,